job board and CV stuff and all this.
Cool.
So, yeah. What else is everyone working on? Anything interesting, like side projects?
Working in there. So I'm the best. The major part of my work is work with Ethereum, and it's starts with Ethereum. It's awful. It's big. It's enormous big, and it's written PHP, and it's very hard to understand what's going on in this system with a lot of legacy code and so on, and every time I work with this system, I'm thinking about why people are not do this like system like in Clojure or just in just in короче, в лучшем сейчас the best just
Подход?
Да, why not doing the better and what are the сейчас я сформулирую в голове, потом это скажу. I'm trying to figure in Russian in my head and now I want to translate. And I think the system are growing so much and in such an awful way, like in this Ethereum, is because they are not at the beginning they are not think what will they eventually do. And so what are the final step of your system? When you can say that we are done over we have, and now we can focus on other things or just plugins or just we will know extend features. We just stop and doing the best what we will do to then for people to adopt it in their company or something like that.
Okay, so when are we done coding? Or done, is that what you mean?
Yes.
Как конечная архитектура?
Да, вот. Когда будет ли просто, проблема, что некоторые начинают там стартап, вот, наделают там MVP какой-нибудь, вот, и потом начинают лепить туда, накидывать, он в итоге разрастается до того, что люди в open source очень часто теряются. Вот. In open source, it's often they are like system are growing, and then people are not cannot understand what are parts are. They are too big to understand the system.
Question of architecture is a good. if you see the final architecture, the destination architecture for Athens.
It's a really good question. On the back end, we kind of finished the architecture. Like what we have today, I think will take us a very long way because it's just like sending events from the client, from the user to the back end. So things like create a new page, create a new blog, like connect these two pages, and that should scale, indefinitely. The front end is something I'm not so sure about, and that's kind of what we're talking about now, because we're talking about, okay, what other things can we put in the graph? Like right now we have pages and we have blocks, and a block is basically like a paragraph or like a line of text. It's like you press enter, you create a block like Notion. But with the graph, we can really create anything. Like we could create chat messages as a data type. And how is that different from a block? It's not that different really, right? It's not a huge difference. We could have different types around users. So like users are kind of a unique type that we don't have in Athens yet. Like we kind of have concept of user, but it's not a real concept. Things like time. Like we have a date page. Like daily notes, like every time you open Athens, it'll open to today's date and you can write things there. But what if you want to do more powerful things, just like show me the last 7 days, or show me like next month. So time is like a different concept. And yeah, I think that part we don't really know yet. And the thing is, like, you can't really know too much before you do it. You have to like build it first to know the architecture. So I don't know how much we don't know yet.
Yes, but I think Clojure it's the better way because there are no OOP, there are no. It's like a better system to build huge systems, better language.
Yeah, hopefully.
Hopefully.
But I wrote a lot of it, so it's kind of shitty.
Yes. It's like if you will try to understand the theorem that includes 10 millions of stroke lines of code, it's like low way.
Yeah. So yeah, what's everyone else working on?
I'm working for a London-based company called Clean.ai. We build these data pipelines for clients. Like this is a SaaS platform, so we build a platform and clients could set up their pipeline, extracting data, transform it, put it somewhere or else.
Using Clojure.
Yeah. Yeah, we use Clojure for front end, back end, connectors, pretty much everything.
How big is the company?
Now it's about 40 people, I think, and yeah, we got first seed round and a series looking into Series B next year.
Nice. Do you think Clojure is good, like for you guys?
I don't know. Yeah, definitely for like application sides, for platform it's good, but yeah, not sure about. We are trying to build as much connectors to third parties, and there's a lot of solutions in Python, and maybe if we would use Python, it would like build faster.
Yeah.
But for application side, yeah, it's totally better.
Yeah. Reframe.
Yeah, reframe, data scripting, push, and on the backend we use Duct by James Reed's
Okay.
library for configuring the application.
Okay.
It sounds like it's based on Integrand, but with some nasty features. After wearing state of what we're doing together. Yeah, and like Visual Kafka, which has a lot of AWS services. Yeah, we fully inside the cloud, it's good AWS. There are all these DevOps services.
Cool. Sounds good.
Yeah, and by the way, like, we're looking for new developers, so someone just a little spoiler.
In Clojure?
Basically, do you have any problems in searching for new developers? Is it hard to find a new
No,
developer?
no, it's not hard.
Do you consider developers without backend experience such as Clojure for backend development?
Clojure script.
I have some experience with front-end and backend with Clojure for my side projects, but I'm doing development professionally.
So yeah, if you experience enough in other languages, you like understand how much things. Yeah, and I think the fact that you don't have real like work experience with Clojure will be big plus.
But Athens is more fun to work at. You learn more. You're smaller. Just kidding.
Regarding Athens, so are there any plans like to expand to other platforms like iOS, Android, such?
Yeah, it's not like a huge priority right now because we're still figuring out, you know, what that core use case is. And yeah, like we wanna make it work for desktop first,
Mhm.
I would say. But we'll get there.
Yes, for the desktop, I suppose my use case is a bit out of scope. Yeah, so for let's say maybe it's not even. Are there maybe any plans to have some import-export function, like maybe into JSON or other kind of things?
Yeah, I mean JSON Markdown is like the first place to start. There's a lot.
So there will be some kind of things.
I mean, eventually we want to do everything,
Okay.
but it's not like again a huge priority because you know we're thinking about different kinds of applications. Like if we're building chat inside of Athens, like you could export that, but it wouldn't be as useful. And we're really not trying to just do note taking. That would be a top priority, and that's you know what our competitors will do because they're really just trying to do note taking. We're trying to do something more entitled.
Yeah, I'm just trying to figure out how can I, let's say, apply Athens not only for my personal use because yeah, it's great, yeah, but I would like a bit more like to collaborate with colleagues. Yeah, so maybe even to exchange the current state of let's say not of all the nodes you take, yeah, but maybe of some, like maybe of parts of the graph, like blocks. Let's say that you can maybe export or import into some kind of format like JSON or YAML maybe blocks, yeah, just to specify block.
What do you guys use Confluence now?
We mostly for our current projects, yeah, and let's say I'm not in the software development, let's say department, but it's service department. So we sometimes use Jira, we sometimes for knowledge exchange, and sometimes internal GitHub, yeah, like this markdowns and such kind of things. But it's some kind of a burden for engineers, yeah, like to pulling, pushing, like committing, and some kind of other kinds of things, searching through this markdowns using GitHub. So I was trying to figure it out if I can apply Athens software, yeah, like for collaboration with colleagues, maybe through Box, maybe or some other kind of synchronization, let's say sharing tools, yeah. Yeah, so
We can talk about that, but I think you'll have trouble trying to do it.
yeah, and as for let's say collaboration on GitHub, so other features or other kinds of things within let's say your Athens GitHub that one can take and implement themselves. Yeah, like
Yeah, I mean you could take all of our features.
yeah, I mean, is there some kind of roadmap or some thing publicly visible? Yeah, so that one can just take a feature from there, implement, and push it back to Athens.
I don't think we have a public roadmap because we've just had because we're building it right now. Like for the short-term future, I can tell you the things we're working on. Like we're still working on performance of our backend. Like, we use it so much that it's slow for us, and that's like a big lesson that we've learned. That I've learned trying to use DataScript, and Rowan saw this too, Logstack saw this too. But, I mean, DataScript is amazing, but we're really the first ones to create a proper concurrent distributed system with it. It wasn't built for that. It was built for like one application, global, basically in-memory database. It wasn't built for collaboration. And people have tried to make DataScript on the front end, Datomic on the back end. That still isn't super mature either.
What are the problems there with this approach? DataScript problems, what do you think?
So DataScript has each anytime you load DataScript, and each person, each like user, even if we're using the same graph on the back end, everyone has their own DataScript indices. Right? And so like you can't use the entity ID that DataScript gives you because every person has different entity IDs. Right? So then you have to have like a backend version of DataScript, like Datomic or DataScript backend or like Flurry or Data Hike. But now you have to like resolve the transactions coming from everyone, right? And the way Datomic does that is that it doesn't do that. Datomic is a single writer.
Yeah.
Right? And so now on our backend we have a single writer, and I'm writing, and then my colleague is writing. It just like blocks the other writes. So now it's like really slow, right? Now it's slow. And so like those are the problems with. We can make it faster, but it's like for the first pass, we just have to get it to work with the way that we were doing it, because if you send the raw transaction data, it doesn't work. And that's what Rome is doing, that's what we were doing before, and it just leads to data loss. Right? So like Clojure is amazing. I love it, don't get me wrong. DataScript is amazing. But these aren't mature systems or as battle-tested system as SQL, GraphQL, right? It's not Firebase. Like it's not.
Are you using GraphQL?
No, I'm saying it's not those things.
Okay.
We don't use it. We don't use GraphQL yet. I mean, maybe one day. And Flurry is really nice, so I recommend everyone check out Flurry because they basically build a graph database, and then they have API libraries so that they have the data in the graph, but they actually have interfaces for GraphQL.
Yeah. GraphDB. Like there are new. There's a database that has an interface in GraphQL as a native thing. GraphDB, I think it's something like that.
Maybe.
Yeah.
No, Krux doesn't have GraphQL. They don't have the GraphQL interface. They only have basically their version of data.
Dgraph.
Dgraph. Yeah.
Yeah, and it's very strange because I'm a huge fan of GraphQL and like developing libraries for GraphQL, committing everywhere to Rust, like to the upstream and shit like that. But and I appreciate the graph databases very much because SQL, like relational databases, they have this nice quality of maturity, as you said, like because they have like transactions, proper transactions, proper distributed.
It's like 40 years old.
Yeah, but like the essence of relational databases, like the tables themselves, like this multi-set mathematical concept, which like this COD guy, right? Like this mathematician who developed like the relational algebra. It starts getting too old for developing. So like you're targeting maturity in like relational databases, you're targeting the maturity of like triggers, functions, all of that stuff that you can use. But you're actually not such a big fan of tables themselves, because tables like have problems in terms of usage.
Yeah, I agree.
And they did this dgraph thing, and though I don't like the SQL approach, this looks very strange, this dgraph, because it's like GraphQL as an interface to the database, which is strange. Like they do some strange, like DSL there, which allows to do wires, but like it works.
I haven't looked into dgraph that much, but what's nice about Flurry is that, and maybe this is the future of all databases, is that it is a database on the back end, but you can use any query language you want. You can use SQL, GraphQL, or something that's pretty much data log
From front end.
from the front end.
Yeah, but you always encounter a problem of permissions and stuff like that. Like if you allow, you practically, there are a lot of projects that do in Clojure, there are all projects in Clojure that allow you to directly query the database from front end. And what you're always encountering is a problem how to make like permission layer, you know.
Yeah.
But, and this is a problem. It's best resolved in a project called Hasura. Do you remember?
Yeah, Hasura.
You know Hasura.
Yeah.
This is a super cool thing actually. It has 1,500 issues on GitHub, or even like 2,000 something, and like it has a lot of problems. But like it has such a nice concept. It's done in Haskell, by the way, and it's practically a GraphQL API layer over the Postgres or otherwise, like Postgres, MySQL, I think Oracle database, and it practically allows you to, like, if you connect the database and it goes to the database, get the schema, and generates a GraphQL API over it, and also allows you to make a permission, layer in some DSL, like declarative manner.
Yeah.
And like this stuff is very cool. That it shows like the direction where everything is going, but it's also not like doesn't seem that like reached, you know. So.
Well, Flurry is also really interesting. Their permission model is that I said earlier, it's kind of like a blockchain. Like there is a ledger, and you can see every transaction gets posted to the ledger, but then it also includes like the permissions with each transaction, so that you only get the transactions that you have permissions to.
Uh-huh.
And that's their permission. Pretty interesting. But
But
it's
if it's a blockchain, it just treats the transactions you don't have access to, or like they're.
I mean, when you're using a client library, the React library,
Yeah.
it'll only update for the things that you have access to.
Okay. But if something is removed from the blockchain, how can you, or like you're talking only about the updates, not about the reading?
Yeah.
Because
And
if
it's
you
not
really-
it's not a public blockchain. It's like a closed source blockchain. So it's like
It's not so-
it's-
Because you understand, right? If you strip some blocks from the blockchain, you wouldn't be able to validate it. It's like not modified or something. Because like if you would allow people to read only certain blocks from blockchain, it wouldn't be contiguous. So
Yeah. So I mean, there's the client library, like the UI React library, and then there's like the other nodes, I guess you'd say.
yeah. Still, it's a very big problem what you said, that it actually, I think this is one of the main blockers to the faster development in general. The fact that you really kind of, if you're modeling your data correctly, you really want to allow users to have direct access to that, you know, like do this data script thing, like when the front end has like its copy in general, like you have tenants or something.
Yeah.
But then you understand that you have to have an abstraction gap between actually like doing something with the data and like not allowing people to modify someone else's data, doing dangerous transactions and stuff.
I mean, it's a huge problem. Like for us, it's a huge problem. It's like, you know, our vision is to have this big global knowledge graph, right? And it's like, well, I don't want you to read my notes. You know, like I don't want to see your notes either unless they're about me. You know, I probably still want to see them, but like eventually we're gonna have connected knowledge graphs where it's like, okay, write this thing, you subscribe to all my notes or all my tasks on, you know, Clojure. We're like open source, we're like startups, right? And I want to listen to your notes about distributed systems and permissions. But like that's an insanely tough problem.
Yeah.
So that's something that we're really interested in solving in the long term. And it's also a huge problem now with a lot of DAOs and just crypto projects where it's like they want to have something like open source, but also not everyone should have this same amount of observability or like right access to the same data.
It's not open source, and source anyone if they didn't access.
Yeah, so it's not pure open source, like, and so really, like, open source has been around for a while, but I think crypto is kind of like the next, like, it could be the next layer, right, where it's like, we want it to be gated by tokens you have, the NFTs you have. Like, you want it to make it exclusive to some extent, but you also, it's a lot more nuanced, you know, there's more layers to it, right? It's like, okay, the person with the most tokens, like, there's levels, there's tiers, basically, right? In the same way that, you know, GitHub has 5 levels of permissions, or like, admin, maintainer, reader, writer, triage, right? It's like owner, right? It's like the things you can do once you have. I mean, and Discord has that too. If you're in Discord servers, you can have an insane level.
Yeah, like I am
specificity.
in Amazon, like one of the most developed things on that much, right? I am because they allow identity and access management because they allow.
The key management with like specific services, like write access to this AWS bucket, right? Like, that's too much for like an end user. But like that's one level where it's insane DevOps that is only used at like huge companies like IBM or AWS. But like for a user, it can be more complex, but also not as much.
They're generally very badly done. Like I mean, the IAM is everybody's implementing Amazon's IAM access because they have a monopoly, and it's like industry standard. So like Yandex Cloud, Azure, like everybody is doing that. And the usage is very strange. It's not consistent. Like it like has ACL here, but then you like have something different there. You have inheritance here, and like it's not consistent. And it has all the vibes of the thing that has had a huge legacy of like being developed. And I'm not sure that the problem is generally resolved. Like that. It's okay because like there are also if you think about it, there are deeper level of permissions that like for example if you think about operating systems that are made by people with high paranoia like military guys, they like Linux or
Mandatory.
Manager, it's not like mandatory, it's called a little bit different. Like the how Linux works. Like it has for each object in I forgot to have the name in English. Actually, I know this in English generally. I recently looked up how it translated to Russian, and it replaced the cache name. So like how do like very secure operating system works? First of all, obviously nothing is allowed at all, and everything is allowed only if you're allowed to touch this object. So for example, if you're talking about like kernel objects like IP packets, I don't know, like some messages, something like that, each of these things has to have some small token near it. Actually, if you're doing a database for this operating system, even each row can have a small token to it, which operating system kernel checks in runtime, and like it's called a token, like you can call it anyway. And if you're allowed to use this specific object, like everything, as I said, like packets, database rows, like modulus of the operating systems, including the instances, not only like if you can use this dynamic library, but if you can use a specific instance of dynamic library. So yeah, it goes all the way down. Like there is less paranoid stuff like capability-based systems, like Android, for example, right? That Android. It's a capability based. You ask for capability to access location, and it gives you this capability. You have this handle with which you work, and it's actually most of the systems are also done in this couple of layers, and underneath you have like these tokens, and above it you have capabilities, and it's all intervened. It doesn't have a strict structure, and above that you have like permissions, like systems, like I don't know. Web server layer permissions, and then IAM, and this whole deal is like it doesn't have an internal structure from like top to down, and this is I think that this is also a problem that a lot of legacy got us into a position that if you really want to talk about security and access to data, you like have so many stuff, and it's all different, and like even though it does the same thing, whether certain user should access certain like data, like certain something. So yeah, like as you said about the operating systems, yeah, there's also a lot of problem there.
Yeah, it's at the very bottom.
Yeah,
Primitive thing. Like,
I mean, you can say like there's like, I don't know, tens and tens of like different approaches, different layers of security.
Yeah.
And if you have a little bit of OCD, it also makes it a problem, because I understand how much of computation is spent on like doing that. I read somewhere that the amount of computation dedicated only to do the decryption encryption in like in the world traffic takes up to like 20% of stuff. So like 20% of like computation, and also like from 10 to 15, I think 12 or something, data going through traffic is just entropy that is added to the like to data for it to be encrypted.
Yeah.
And yeah, this is also like a little bit like for people with OCD, it's a little bit mad. Yeah. Like when I'm thinking about it, I'm just trying not to think about it.
Да, явление, надеюсь, никто не против съемки,
Не понимаю.
потому что просили взять и напитки угощать там всякие шоколадки. Да, там есть тоник, камбуча. Can you share how you model this in a graph, the permissions and all? Do you do?
Well, we haven't done it yet. We haven't done it yet.
Do you how do you do edges? Do you have edges in the graph? Do you model this in
Data script.
Yeah.
Well, the way we're modeling it right now is there's basically an association. I forget what it's called. Data script where it's like, well, ours is called block ref, and so there's a block. It has a block ref, and then it's an entity attribute value. So like entity 1 has the attribute block ref, and then the value is another entity ID, so 2. So 1 has a relationship with 2. That's it. Now if we have different types of blocks, then we might have to have different types of attributes for that. But we just would have to know all the types of relationships we have. It's really easy, I guess, data script.
Yeah. I'm trying to figure out like myself the best approach to model graphs and to the permissions on the graph-based architecture. Yeah. I thought about like doing, well, not in terms of any particular database, but general architecture. Usually, one of the general approaches is doing like access rules, right?
ACL.
Yeah.
ACL or RBAC.
Yeah, but you like the problem with permissions on graph is going to be a general problem of graph traversal, right? Because if you want to check if a person has have access to a node, you immediately encounter the NP-complete problem of how to get to the nearest like point which you really want to check. Like for example, if this is owned by somebody, some guy, and this guy shared access with you, so you like this is a problem of traversing the graph. Like it's a known problem. It's like 100 years old. And, like there's Dijkstra algorithms, ASTAR algorithms, and everything else, and you will have the same problem. And relational databases have less problems because they are more rigid. They have other problems with that. But there you can like directly check that. Some people do very strange stuff, like they practically denormalize, if you can say that. Denormalize the database very much, even the graph database. They know if the object is going to be checked against, the node is going to be checked against some remote node, then And like this is the main way to check it. Like there is a node here, and for example, there is an owner, and there is like shuffle of nodes between. And they're just gonna create a small helper like connection directly to that node, so you can check against like the edge, you know. But this is practically like materializing.
Cache.
Yeah, like materializing everything, you know, all the variants of access that can be done, and this is. I don't know.
Yeah, we don't have any of that yet. We just everyone who has access to our graph just loads the entire graph,
Yeah, but very convenient.
which is our startup team of
Yeah.
5. You know,
It's very convenient.
so we have like a password.
Do you store cycles in the graph?
What do you mean?
Cycles. I mean, like you have block graph to from A to B, from B to C, and from C to A pages or blocks.
Yeah, I mean that's possible, of course. And you could just click through it, and it would take you to a page, and then you would end up back at the page. But like it doesn't express that specifically. We only show like one step away.
Okay,
at a time.
so one step.
Yeah, one step. So you could click on each one, take it 4 steps, and you would end up back in the same place, but it wouldn't tell you that there is a graph, like a cycle there.
Yeah, just that if you have a cycle graph, then the permission stuff is pretty much straightforward. I mean, it's not an NLP problem. If you have a tree.
Yeah, if you have a tag, yeah, most so likely it's not hard, yeah. But it still can be pretty hard because yeah, you can like have you in certain situation you will have to go up multiple times
Yeah.
request, for example.
So an example of that, even if it's a tree, it can still be pretty hard. And an example would just be a file system like Dropbox or Box.
Mhm.
So let's say like A is like the root node. If I share like B with you, which is like a child, and then I share like C with you, does the person know that B and C are at the same level in the hierarchy? Right? Like if A is the root, and then one level layer is B and C, and I share B with you, and then I share C, like should you know that like B and C are siblings? Because that actually tells you something, right? Like, right? So in different layers of nesting, right? And then like let's say there's D, which is like a layer of B, it's like, does it know that eventually? It's like, so it's not even trivial with a tree.
Okay. So it's like not trivial conceptually. I mean,
Conceptually.
like, so it's hard to decide how we should like not to implement, but to conceive the permission system itself.
Yeah.
So what would be right for permissions to be, not like how to implement it, right?
Yeah, I think overall, at the end of the day, we are focused. I mean, the challenge with what we're building, the problem space that we're in, is that we have to solve both the interface problems as well as data problems, right? So like DataScript doesn't normally work with currency. We have to build this entire backend. Half of their startup has been building just the backend to make it work and not crash, right? The other half is like building on the front end. At the end of the day, the user only feels like they only use the interface, and that's where we want to innovate on. But like any knowledge base, you know, it's both the interface as well as the base, which is database, right? Like the biggest problem with Notion is that it's slow, right? But it's supposed to be a product with beautiful design and great interactions. And that's the problem that we have now, is that like we want to innovate on the graph model and explain to users what a graph database is, what a knowledge graph is. Because most people, no one knows what a graph is outside of computer science and math. People know what SQL is, but they don't know like what a graph is. And so one is like figuring out the right way to educate users on the concepts and the model, but then the other is like, okay, graph databases are not very mature technology either. The biggest one is Neo4j, and it's still probably, you know, a fraction of what SQL is.
And it's also very slow.
It's very slow, and like, I don't even know, it's like not, it's a different kind of graph that we're using.
It's unpredictably slow. Like I tried, I don't understand sometimes why it just slows down certain things.
Yeah.
Also, it's based in Java, which is from one point of view is good that like you can use a Clojure interface to it, for example. But from another point of view, you understand that it's not going to be as fast as Postgres.
Yeah,
Ever.
it's pretty slow. So I think overall, like figuring out in terms of what we do, it's like we want to figure out the product, what it should behave like to the user first, and then solve the data problems. because we could solve data problems forever and not actually change like the user's lives.
I'm planning to do like with the data layer. I'm planning to do stuff like duplication, and I don't know, like if some people are using the same link, you know, to something, and like are you gonna store like the same entity for both of those users, or are they gonna have a separate copy of some knowledge bit? We're planning to do this.
So can you explain more like example? of that?
Was there some kind of block references or
Yeah.
something? Yeah.
So yeah.
So the concept, how it works.
So you can think of a block reference as like I'm linking to a specific line of text. Think of it like a URL. You have like a URL
Yeah.
to like a specific Discord message, or you're linked to like a specific Slack message. If it's like one graph, then everyone just sees the same thing. But now for different graphs, we have to figure out the permissions model for cross-graph references. That's not we haven't figured out yet.
Also, besides this permission-based control, also you might face such kind of thing as confidentiality control. Yeah, so or I suppose it's called privacy control. Yeah, so which parts of the graph it can be shared with other users, which cannot, and it's not the same as the concept of permissions. Yeah, so I mean this is in terms of some kind of governance or something. Yeah, so let's say in Box you might have these kind of things. So besides permissions, you may let's say constrain the level of confidentiality. So this can be shared internally only. This can be shared with let's say subsidiaries or maybe let's say contractors or some other kinds of things.
For example, if there's a password stored in the box.
For example, or some kind of information.
Yeah.
So this might also be, let's say, one of the things. And in terms of graphs, just the additional thing to think about, besides the permission control.
Yeah, there's a lot. Yeah, there's a lot. Yeah, we haven't gotten there yet, so that's why it's just everyone sees everything. But,
There's Athens open to be if you want to show block references.
yeah, maybe easier to explain.
Yeah, you can use that knowledge.
So let me type something first, like that's in Russian.
Space.
Something like graph databases are flexible but hard to use. So I don't know, like how many people have actually used that? You have.
I just tried.
Okay.
I download, but I don't.
All right. So maybe like pass this around. So let me see. Okay. So this is like it looks like basically a taking out, right? And this is a block. It's just a bullet. And a statement like graph databases are flexible but hard to use compared to SQL. This is the source text, and this is a reference. It's highlighted in yellow. It's like basically referencing this previous block so that anything that is written here, it shows up here. And that's really like what a block reference is. And the other thing you could call it is like a transclusion. So if I update anything here, like add a bunch of numbers, it would show up here as well. So it's like a live copy and paste, like an embedded pointer. A pointer, yeah. That's another way to think about it. It's like rather than just writing the same function every single time, or like the same, you can just define a variable, right?
Yeah.
Like this piece of knowledge is a variable, and I can reuse that in different
Data
contexts.
abstraction.
Yeah. Like imagine if you didn't have variables in programming, how hard that would be, right? Like,
Functional programmers.
very functional, right? So it just derives it. And all this is like a UID to the block, a unique ID to the block. But you can think of it as like a URL. So it could be like athensresearch.org / the company name / ABCD1234, right? It's the same thing if we copy a Slack message or copy a Discord message, or like copy the specific link to like a Figma component. That's all it's doing. And it's all internal. We only have one graph. But long term, there's huge questions around, okay, how would this show up in a different context in a graph that doesn't have those permissions? Like, it should hide it by default. But if you subscribe to this thing, say I change my mind, change my notes, be like, oh no, graph databases are actually really awesome, like SQL sucks, and like you have subscribed to that block. Should it update in real time? How should it notify you? What happens if I stop sharing that block? Do you get to see the old block? So it's almost like you can think of it eventually, maybe a better analogy would be like NPM or like module system GitHub, right? And it's like, it would be horrible if the NPM packages updated themselves, right? And it happens all the time, right? Like you want to lock the dependencies, and like even though sometimes people do that, there's still problems with that, like log4j, right? Like, there's just like a bunch of like Amazon, Google, IBM, they were all at Congress in the US this past week talking about that, right? And so at the same time though, like if it's stale and you should just like stop working for some reason, like you also want to get notified that like the dependencies change. You can think of that like this, like eventually we're gonna have to build a dependency mapper to create the dependency tree.
Also, what excited me the most is that not only just these block references accessible, but also templates where you can just copy the block from, let's say, another page or something like this, and it won't be the reference. So it has both sides, so block references and templates, so you can either copy or just reference the block, I suppose. So it's these templates I've already found them useful. So for example, we do have so-called architectural methods. So in architecture, within which you do have some phases, maybe work products, roles assigned to, let's say, each architecture. And it's some kind of what I would like to do.
We have templates in Athens.
So what I'd like to do is some kind of checklist. So if I've got this kind of products, working products here, like for example, functional, non-functional requirements. If I've already made architectural decisions here, just check these checkboxes and so on. So I've made this external page with where I just describe these phases, these work products, and each time with a new project, I'm just using this template, and it creates this block for the new project within which I'm just ticking these checkboxes and so on. So it's I found this very helpful. This kind of functionality.
Do I understand correctly that there can be like a node that is only references to a lot of other nodes? Like it doesn't have own like content, it only references other nodes, right? It can be done. So you can have it's also like an abstraction, you have like more and more like nodes that don't possess their own info, but you just aggregate a lot from the lower level.
Right. You could do that.
Do you plan to add some kind of summarization, like using machine learning techniques?
Yeah, that's a good question. Maybe. There's actually a startup doing that, and they're focused on serving DAOs, but they've added, I think, direct integration with GPT-3, where it has some prompts, and like I think all it is a plugin, right? Like all it is a plugin which hits like OpenAI APIs. people, there are interesting use cases there where it's like, it'll give you prompts to be like, okay, what do you think about graph databases and like SQL databases?
Mm-hmm.
Or it'll be like, combine my notes and write a paper for me, right? Like, that's the dream, where it's like you don't have to do anything.
Yeah, but also like stuff. If you have a serious graph, you wanna, before you start diving into like node that has a lot of like connecting stuff, you wanna check like what's it about. Like it's a rabbit hole, and if it's gonna summarize it for you, like say okay, here is like the info about the crusade of relational databases versus graph databases and stuff, and like. You can also even probably summarize like general opinion is that like this stuff is better. You know how they do on markets, like they summarize the reviews.
Yeah.
They summarize the reviews because all the systems, all the data knowledge systems, they get abused. Like when you start Confluence from scratch, it looks so nice.
Yeah.
Everything is there. You think like all of the pages are gonna be like fancily distributed and stuff like that. But even if everybody is very like accurate and stuff, at some point, like I don't know, you're gonna have, for example, 3-4 iterations of system updates. Like a large system, there is a Confluence describing the system. Then one team did the system. Then in 2 years, another team did the system. And some other stuff, and then if you go into the search and input something, you're gonna see like it's very like I don't know, ask for I don't know how does the service works, and there is like a shit ton of different information, and it's Confluence, and I am certain that the graph data can like have even worse qualities in that sense because like it can be like very much interconnected, and and generally speaking, you wanna. When you work with such systems, I understand that this is generally more for research and like sort of thinking and stuff like that. But somebody is going to use it to store like the knowledge of the company of like some I don't know work, and then they're going to try to search, and they will not find what they want. They will find a lot of information just lying there without understanding what's it about. So yeah, it would be probably help of artificial intelligence would be very applicable here, but it's like a general thing for all knowledge systems.
Yeah, exactly. And that's why I don't think too much about like the AI applications to us, because you could just apply that to any body of text, right? Like you could apply it to Notion, you could apply it to Confluence. You just have to have the index of all this text, right? I think the things that are unique to us that maybe like, you couldn't do in Notion or Confluence would be, maybe there's two, and neither we've fully explored yet, but they're just, so one is that we could apply more metadata. So the thing about the graph is you can kind of just add as much metadata as you want, an infinite number of attributes, values. Eventually what that metadata does is, what that means is that there's different types of knowledge, right? So you could say this is like a summary block, right? This is a argument, or like a piece of evidence or a piece of claim, right? And like through that, actually have a higher level of argumentation or like higher level of extraction from the knowledge graph. So one thing that some people have done in our space is create this type system called a discourse graph. Mm-hmm. And it's like 5 types. So there's a claim type, an evidence type, and then the edges are supports or refutes. Mm-hmm. Right? So like with this like 4 or 5 types, you can actually reduce every single academic paper to these dimensions, right? Mm-hmm. And then you can connect them, and I can say like, I'm writing a new paper, these are the claims that these 10 other papers made, and I'm using them as evidence, right? You don't have to read a 50-page paper again. Yeah. You just have the core primitives of the paper. And then you can do the same thing that I was talking about earlier, which is build a dependency graph, right? So if this paper turns out like, oh, vaccines are actually good for you, right? Then it can debunk all the papers and be like, oh, sugar is actually bad for you, right? So you know that it doesn't automatically update it, but it automatically does tell you how the dependencies are affected through that, right? And that's like a huge problem with science, which is that like people make the study, they'll say it's true, turns out it's wrong. Same thing with, I mean, American media, I'll say American media, is that like they'll say this crazy claim, like, oh, this person did this thing, they're a bad person, and be like, updated 12 hours later, it's like, oh, sorry, you didn't do that
And
thing.
it always reaches less amount of
Right, and no one cares at that point, and the truth is already too late, right? And so like, with this kind of type system, this small ontology, you can actually express so much more knowledge in a much denser way, because it's structured in a way that we agree on.
Yeah, there was a lot of attempts, like this is a very known problem, like a lot of attempts to automate science in that sense, like the people are proposing to write articles in Python, like that you paper sort of like we write a paper in Python in the way that it has internal structure that can be validated and like you can reference this and even like has functions of some sort of within that you do and no one does it obviously. And like this is a very big problem actually what you're saying. It's a very big problem because there is I forgot the name, there is a limit of like how well humanity can control the information, like also the limit of management. I didn't remember like the name of the guy who said it, like, but there is like, for example, it's known that the person can properly manage like 7 people in general. Because like there is this a magic number from 5 to 9, 7 people, and it means that at some point it's a management or science. Like if there is going to be more than 7 specializations on certain topic, and this guy does organic chemistry, this guy does inorganic chemistry, this guy does some other chemistry, minerals, etc. And the guy at top of them will no longer be able to conduct anything else. He will just have to manage them. And at some point, if the knowledge is too wide, then the system doesn't have a capacity. However much people you would have, I don't know, 10 billion, 20 billion, you will not be able to work the information, and it requires automatization of science and or other things. And the problem of like connection between like all of this data is very big, and like I don't know how people are gonna be solving that, because obviously like the paper that are done in the modern era, like the best kind of automatization they use is latex. And like what is this? Like what does it give you? If anybody will have to read like this paper and disprove it, and like this whole deal that she said, like that there's a cascade of events that should happen and it doesn't happen, and everybody's like, no one knows what's the state of science currently. So yeah, this is a big problem.
So yeah, that's one solution I would say. And it's funny because like we're just building this knowledge graph, but it actually has a lot of the same goals as like AI, but really with small data, and it's just in how we structure the metadata we add. The other kind of metadata that is underexplored in kind of just separating signal from noise in knowledge would be the browsing history.
Mm-hmm.
Right? So like, if you just do a plain text search, it's only going to tell you so much. But this is another area where it's like, what if you could see the paths that you took through your knowledge graph, and that was actually relevant for which results are shown in the future. So I guess maybe it's kind of like Google's PageRank, where it's like, okay, these are the most referenced pages, but it's actually looking at the browsing context, right? So like, that's an underexplored area. Of like, if no one looks at their browser history unless they're like looking for a specific thing. But if we did somehow decentralize that data, but I guess just centralize the data, but in an anonymous way, in a private, secure way, we would actually have a map of basically knowledge that the world has, that every person has walked through. Right? Like, these are the paths that people took to learning. Like, say, like, I learned Python, then I went to like this YouTube video, then I went to this blog, then I went to like GitHub. If we actually aggregated it and found all the paths, we would have a global map of knowledge.
Yeah,
but
we
don't
optimize
use that
for something.
right? And we don't need to do that at the global level yet. I'm not saying that we should do that because probably only Google is capable of doing that, and you don't trust Google, right? But we could do that within the local graph itself. Be like, okay, Jeff went to like today's date page, then he went to the graph database page, then he went to the SQL page. That's actually rich data that if you aggregate that across many sessions and many different users, could be fed back into the graph to tell us which results are the most relevant. That's an underexplored, and I don't think that, I think there's a lot of those things where we're using like small data on a graph and feeding it back into the graph to tell us more insights that we don't have to use AI for. Right? All that Athens was in Rome and all these guys did, like, we just added bidirectional links and like the ability to link to a specific piece of text. It's not like a hard tech problem. It's really just applying some graph theory and giving a good experience to users. And there's so much more of graph theory that hasn't been used yet, from like the semantic web and from ontologies, from like just graph theory. So I think there's still a lot of opportunity there without having to do AI to make it a lot smarter.
What you just said is practically the way neural reinforcement works. Like you have multiple neurons and you walk this path a lot of times.
Exactly.
You're gonna have a better connection, like perception works this way. Yeah.
Right, that's how neuron works. The pathways that you walk the most are the ones that become the strongest over time.
Yeah, so at some point you have a shortcut.
Yeah,
Essentially it can be a problem.
Right.
You know?
So like, why can't we do that in our browsers?
Yeah.
Right? Like, why can't we do that in all of our applications? Right? Like, why do it split across? Like, why am I messaging? You know, I've been on Twitter and then like Telegram, and then like he's messaging you guys. Like that, if this was all connected, like it could be so much more powerful, and so it could just change like how we are using these devices. So it's not really applications, but it's really just a graph-like operating system, and it preserves the user's intentions, not siloing the data in apps, but having a concept of like messaging or concept of like IDN across all of them.
I just thought that it would be really nice if there was some kind of functional, not just to process all of your graph, yeah, but maybe just one page, maybe even embed some code into the page, yeah, to somehow process like, parts of the page or something. Yeah, so it would solve my question with plugins at least. Yeah, so within this page, if let's say you can use some kind of, I won't say DSL yet, but maybe Clojure.
Clojure.
Yeah, just embed a function in Clojure, for example. Yeah, like for meta, some kind of meta processing of the page.
Yeah,
Once you open the page, it calls the function within this page.
Sure.
Then you can just, let's say, bind some events to these functions that reside within the page.
Exactly.
So let's say just start processing, it processes your graph maybe on this page, or maybe on subsequent pages, and so on. So it would be great and let's say more extensible than just kind of plugins on front end or even back end.
Exactly. So what you're describing is kind of the concept of using your knowledge graph as a REPL, or like a Jupyter notebook, where you have the data, it outputs more data, and then you can feed that data back into the results, right? So it's like a live environment, like Smalltalk or Clojure REPL or Jupyter Notebook. That's super powerful because again, the point of the graph, like one of the big insights is that like there isn't a difference between like metadata and data, and in Clojure there's no difference between data and code, right? It's all just data, right? And when you can really just combine them, express them, compose them, so it's super powerful. And we've talked a lot about what you said.
So how complex is it to implement such kind of thing? What do you think?
Well, I mean, I think everything is possible, right? It's just, is it a priority? And I think what you're doing, you can kind of do in Rome today with JavaScript, and I think they have some Clojure script support as well. But I think we're not there yet because we want to make it more accessible to users. And that would be focusing pretty heavily on developers. Right? And if there's a way to make it accessible, to have the power you're describing, but it's accessible to anyone, to non-developers too, like that would be good. So the good examples there are like Google Sheets or Zapier or like IFTTT, or like Apple Shortcuts on your phone, right? It's like your Apple Shortcuts lets users create programs, but you know, low code.
Low code.
Yeah. So, I mean, for the MVP, yeah, of course we want to support Clojure, but one, it's like not super safe, I guess. Like Chrome does that, and like when you do it, it's like not safe. And two is like we want to figure out the usability and not just make it a tool for developers, even though we are open source. Like we want it to be accessible.
So what I have been referring back to my pet project which I abandoned. Yeah, so I've been thinking about doing pretty much the same. Yeah, but I've implemented this so-called cards. Yeah, with for dashboard with some kind of DSL, which was Clojure. Yeah, but it was validated, I suppose, as schema, Clojure schema. How it's called this? When you validate your
Spec.
Clojure spec, it was validated using Clojure spec, yeah, so some kind of, and it was just written as a bunch of macros, yeah, which were evaluated, but previously checked with this spec. So that was the way, yeah, so I was doing this, but yeah. It might be also not that simple for, let's say, some common user, yeah, just for advanced users.
Yeah.
That may be reasonable to do something like this.
Yeah, I mean, that's the dream, like, where it just automates a lot of things for you in like a low-code way. Like, oh, when I create this tag or this link to a block, give me the ability to like create a task or send a notification to my other system, right? It's just like Apple Shortcuts or IFTTT. Like, oh, in the beginning when I open my computer, give me my daily routine, like fill my inbox with all my emails and my tasks and messages I need to respond to, right? And then at 10 p.m., like turn off the screen, like get a coffee, and like, build your own workflows. Like that's the dream, right? Like that is, I think, that does come like. I don't know what priority that is. Like, it seems like that is built after, like, those are like the actions, I would say. The events. To me, that's like the other analogy is like GitHub Actions, right? It's like once we push the code, we like run these workflows, run the tests, run the linter, and then maybe like do the performance test. And then eventually, if it all passes, create the DMG, the executable, like the Uber jar, whatever, and then do it. So I think the GitHub Actions is a good analogy to that too.
Yeah, so at first, just to, let's say, to implement this kind of events, yeah, I suppose, like opening the page, like maybe some schedules, like maybe some binding to, I don't know, buttons or menu, and something, yeah, and afterwards, the logic, yeah, so to be that implemented in some kind of DSL, Clojure, or be that some kind of low-code system,
Yeah, I don't know. It's pretty far away, I'd say, yeah, but yeah, just like hooks.
You said you have 3 developers, and is it enough to support?
So, I mean, I think that like we're still getting to product market fit, like, figuring out the core use case. My style or my belief, and this is what also like Y Combinator tells us, is that you just shouldn't hire many people until you have a lot of more demand than supply. Right? Until like all of our servers are breaking and people are giving us money, but we can't even like take it because we're too busy. Like we shouldn't hire too many people. I think like you can hire a bunch of people once you raise like a Series A and like you're making a lot of money and like it's very like you know exactly what button to press to like make more money. But before that, it's better to be small so you can like change and iterate, pivot. And that's like one. I guess everyone here is working remote? No? Yeah. Like you don't.
No.
it's just like, I don't know how you, I mean, it's different when you're like kind of the manager, like what I am, like, it's harder to just change very fast, right? And even if you're not a manager, like I think you experience that, like, you have to schedule a call, like send a message, they don't reply because they're like feeding their dogs, you know, like it's harder to pivot when you are bigger and when you're remote. And we still at the stage where we need to move very fast and like constantly change the strategy, change the roadmap, change like the direction, focus on business, focus on design, focus on engineering. Like it's hard to be fast when you're big.
Well, it depends. I think. Yeah, I'm just comparing. We have 12 developers now. Camp engineer. It's like there's a hell of a lot of things we just can't cover because we don't have enough free hands.
Yeah, I mean, there's so much we want to build, but also, you know, the mythical man month. It's like just because you add more developers doesn't mean it's faster. Because there's onboarding time too, and then there's coordination costs as well.
Not everything is parallelizable.
Yeah, actually, I wanted to ask a very similar question, but the opposite. I heard that you have 5 developers, am I right, or 3?
3.
Oh, 3, okay. So
Well, 2 senior developers, a junior developer, and then I'm coding a little now.
okay. So I was about to ask, how did you organize the transition from you as a single developer to a team of developers? As I understand, it was like a quick transition, right? So
It was pretty quick. So like it was just me coding. I mean, me full-time coding for a year, and we had a lot of open source contributors for like the first year as well, and that's its own kind of art, I would say, of like managing open source contributors, because like half the time it's like not really useful, and like half the time it's like it's more work than it is to give a good review and to give feedback and to like just tell them what to do versus just like doing it yourself or just like closing it and ignoring it.
And you also,
Yeah, so it's
you gotta be very polite.
it's very managing open source is its own art, and so it's mainly me coding full time the first year and doing that as well, like being a maintainer. And then after the first year, we had like 2 senior engineers join, and then a junior engineer joined a little bit later. Like it was like, you know, it was like May was like first engineer, then like June was like second engineer, then like July was like third, and it was not too hard, I would say. Like I stepped away from it and I was fine because I'm like pretty hands-off as a person, and at the end of the day, like our 2 senior engineers have way more experience than me. Like one of them has been Clojure for like 5 years, one has done code for like 10 years, maybe like two years and like 10 years, literally. And for me, like I just trusted them a lot and I backed off. And there's a lot of founders that are not good at that, a lot of managers that are micromanagers, and I'm not a micromanager, I don't think. But eventually, as we were building it, it got like, things were taking longer than I was hoping or expecting, and eventually I was like, guys, what's going on? I was like, I'm gonna code again, like, and they're like, and now, starting last week, since the new year started, I started coding again. And part of the reason is that I was in America, and they were both in Europe, and so I couldn't go to the morning stand-up with them. But now that I'm in Europe, and I'm ahead of them, like I can participate, and I want to participate. And I think that things are moving faster. Myself, I think things are going on faster. And like, it's also just a matter of what we were doing. So last year when we started working on the backend RT, like real-time collaboration, we also didn't really know who was going to use it. And so I was spending a lot of time doing interviews and sales to figure out what are the use cases for this. Like, are we going to sell to startups? Are we going to sell to big companies? Are we going to sell to business teams or research teams? Are we going to sell to remote teams or office teams, like in-person teams? So like I also had to do that. I had to step away from coding to do that, to figure out the business use cases for us. And after we did that, I did that for a while, and I had help. We had like a chief of staff for a little while who's doing basically this kind of stuff with me. You know, we really figured out like the kinds of companies that could be using us. Not just companies, but also we also talked to DAOs, and we also talked to nonprofits, like charities, like public policy groups, and we kind of did a lot of that. And now that we have so much knowledge there, like I don't feel like we need to do as much there anymore. We just have to like build the thing because we have a good idea of who we want to be using us, who we want to sell to. So like there was a reason why I stepped away from that, and now I'm back here because I feel like we have a good idea of who we want to serve next, what we want to build next. And now, like, I can just focus on this. So it's been interesting going back and forth.
So you share like architectural and the technical knowledge through Athens, right? Inside the team. I mean, so you have this problem of sharing knowledge between different developers.
Yeah, so we do now, but when we were building RTC, Athens didn't work. So we were using GitHub and Notion and Google Docs, which is, and then Discord, right? Like that's the problem now. So yeah, it's an interesting thing. But now we do project management inside Athens. We also used Trello before in GitHub. So after we got Athens to work internally, we don't use Trello anymore. We don't use Notion. We don't use Google Docs. The only tool that I think we use for knowledge sharing that isn't on Athens is probably GitHub. It's like GitHub issues and pull requests, and then Discord, I would say. But that's what I'm saying. The last thing that what I've been thinking about the most is how we can put chat inside Athens, because to me that's like the last place where the most knowledge is lost that isn't captured in the graph. Exactly.
So you also mentioned mythical man-months, right? So and in the book, he talks about the like ideal teams of surgeon and copilot and all this.
Yeah.
What do you think about it?
That's such a good question because we actually started doing that like last week. So RTC was the mythical man month. It took like 8 months. Like I thought when I first asked Alex, he just joined. I was like, how long do you think does it take? And he's like so embarrassed by this, but he was like, yeah, it could take 2 weeks, it could take 2 months. And then it took like 8 fucking months. I like wanted to kill myself doing it. It was so bad. And the thing is like, it's not that time is linear either. Time is like exponential because like in the last one, every day feels like a month, right? Like if you have to pee and you're like in the car, the last minute feels like forever, right? And so we're like, okay, we kept on thinking like, why did this take so long? Like what were all the things we did? Like, and it was a fundamentally hard problem, like what we did. And you know, some of the lessons were like, don't do random shit. If you're doing a hard problem, just focus as much as you can because you know, maybe it took 6 months, so I think it took 6 months total. But for like a month or two, we were also doing other things, and we should have just completely focused on that, right? So it would, if we had just focused on the essential complexity, we wouldn't have the incidental complexity of like, oh, these are all these other features we work on. It probably could have been 4 months instead of 6 months. And again, month 6 is like 10 times longer than like month 5. You know, it's like 100 times longer than month 1. Month 1 just goes by like that. But you know, 2 weeks ago, at the start of the new year, we actually changed basically our project management strategy to. It's funny. This is so basically this is my first time talking about this like outside of Athens, but we have this framework. It's called like a fruit framework. So we have like one big project at a time, and we call it the juicy fruit. And then we have a bunch of small things, and we call them low-hanging fruits, right? And then we have like a medium-sized ones which are open, and we call it like sliced fruit. So like if you don't finish it, it's gonna go rotten, and you know you should just like finish it. And we decided we're gonna do one juicy fruit at a time, and one person is gonna lead that project at a time, which is the surgeon, like mythical man month. And then everyone else is going to support the surgeon if they need anything. And the idea is the surgeon pushes through. They like come up. First, we come up with we decide the problem, we decide the scope, we decide the MVP, and then as soon as the MVP is demonstrated. So, for instance, right now we're working on undo, And we don't have undo inside the graph because we have to figure out. Like it's funny. Like we don't have undo because it's like we're using a graph database.
Yeah, so I faced it.
Yeah.
So
it's like
you're just pressing Command Z and your graph is.
Yeah. So like I mean for local it works because we just like drop the database and like restore the new one.
Not in every
But
case.
yeah, not in every case, but like for the remote case, we don't have it at all because we have an event-based system, right? And so in order to implement undo, we have to implement it for the 10 operations that we have, which is like block view, block delete, page view, page delete.
Reverse for all.
We have to create the redo, yeah, we have to create the reverse for all those things. And so, and there's like a list of like 12 operations that we have. So Philippe, who is one of our senior engineers, he implemented undo for one of them. And then on Thursday, me and the other two engineers, we all started doing the other operations, right? And so basically, he did the hardest part that he could do all the way to the end, and then we implemented and then parallelized all the things that we could parallelize. So now like everyone else is doing the other operations, he's still doing the hard ones. And the idea is that if we just focus on this, we can ship, like it's something, and if we focus on it and like help when we can help out, it should take like half the time, whatever, if he was just doing it by himself, right? And then it's just so much like higher momentum, so much higher like velocity, and like morale when we do it this way. And we just started doing it this way, but like so far, I think it's going pretty well.
And like this like head horse, he explains like what the path he traveled through, right? Like
Yep.
he gives you like some introduction to the problem, how it results, where
Yeah.
it points.
And then, because we all implemented the other operations, and there's like 12 of them, that's actually the best way to share knowledge. Right? It's not documentation. It's not writing it or giving a meeting and talking about it. It's like you guys all doing the thing right after I explain to you how to do it, right? It's a tutorial, it's a how-to. And like we don't have to worry about like the bus factor, right? If he leaves, we all implemented parts of it. We all understand it now too, in a way that's better than just documentation. Right? It's like the best documentation is like no documentation, right? And the best code is like no code, right? It's like we all understand. Yeah,
Risky.
yeah. But it's different, right? It's like we don't have to like read it. We just know how to do it now. So we'll see how that continues to work out. RTC was like one of the hardest things I've ever gone through in terms of like engineering projects. It was for sure, and it was for like some of them too.
RTC stands for
Real-time collaboration. It was just the concurrent thing that we have. But I think that we have like a good system now for doing things. But I used to think that the surgeon thing from the Mythical Man Month was like bullshit. Like, no one does this. I never heard of it. And then we ended up doing this thing where it's like, it makes sense to have one person leading a project so that they're accountable for it. Because you need to have the responsibility. When like 5 people are responsible for something, no one's responsible for it, right? You need to have one person do it. Like, it's fine if that person rotates. And we have 2 senior engineers, they're both really good, they can both do it. Maybe our junior engineer will try it.
Also, access to knowledge in one person's head is quite faster than through email,
Yeah.
because the cache is very close there.
Yeah.
I have a question. You say what the best way to share knowledge is collaboration development, but what about big projects? When a project really big and live 10 years or so, if programmers share information and collaboration development, after some time every programmer is find another job, and fifth programmer find another job, second and third, and in project have parts that no one of current programmers work at any time, because all programmers go to Google. And
they're all on Yandex.
what do with this type of project if you not write documentation?
So I don't know. So we do write documentation. So I don't want to make it sound like we didn't write any documentation. We we do write specific architectural decision documents, and you can see it on our GitHub. It's in our docs folder.
ADR. So
ADRs.
you're using ADRJ or something?
I don't know which format we use, but it's a very simple. It's not even like we follow it very tightly. It's just we do have that. And then again, within Athens, we have a lot of notes about the discussions we have and the articles that we read to get to the solution. And it's documentation. It's not documentation the way we think about it, but it is a documenting our thinking process.
Yeah, so I can just confirm, yeah, so in architecture is the most essential part to use these ADRs. Even when you're certifying as an architect, yes, for the certification project, they do not require you to just, let's say, put in some diagrams like a component model or something. They are required within the process of thinking for you to have these ADRs. Yeah, so like system context, functional requirements, and these ADRs, it's everything you need instead of documentation. Yeah, so you don't need your current state documentation because it will eventually be outdated.
Yeah.
So you might, let's say, forget to update it and breaks up. Yeah, but when you do have some well-documented process of thinking, like this architectural decision records, it's all you need.
Company that I work at now do the same. It's at now through the documentate who we make some decisions. But at no problems how find this documentation is in most is Drive.io. Stored in Drive.io site, and no way to find when every on programs go to another places. No way to find these documents is Drive.io is even we have Confluence and no way to find this documentation.
So I mean, we are basically solving documentation a different way, right? By like, if the thinking process is there, it should be there. In terms of the code part, like we probably can't solve that until we have also an integration with like our code base. But that is, the next level, right? Because it's like, hopefully we'll get there one day, but that's very far away as well. But putting the code base, right, and like parts of Git and GitHub into Athens itself, that would be the dream.
You say what we must place documentation just in GitHub near to code, or?
I mean to say that like, even though we have Athens, there's still a split, a disconnect between our knowledge base and our code base, right? And that's just the problem that hopefully we can solve one day, right? But like that happened, it's already really bad today. Hopefully we can make it better. But like that problem will always exist. Like knowledge is always lost. So like, just because you look at the GitHub, just because you look at the code base, it's not enough. Even if you look at the comments, it's not enough. Then you look at the Git, it's like not enough. Then you look at the PR and issues, it's not enough. If you look at the Slack and the documentation, it's still not enough. Like it always gets lost, and we're just trying to connect a little bit more.
Do you link like the lines of code in Athens? Like,
no, we don't do that. But like again, if we had better integration with things like permalink or like source graph, where it's like you can link to specific lines. But again, we would want it to be better than that, right? Like I still think that like linking to specific lines of code, and even linking to a specific block in Athens is not. That's still a lower level of abstraction. I mean, that's possible with Git, but it would be ideal if you could link to like a specific function. Right? Or like link to a specific variable and see all the context where it's used. Source graph is good for that.
Like linking to the
symbol.
Function or module.
The symbol, not the line.
Yeah.
Right? That's a low level of abstraction.
And then once you, let's say, can refer to some kind of function, something, you can just blend it to events. You're just talking about. So it might be not only just for knowledge, but for execution within
look at the logs of those functions.
You know, it'd be super cool. Yeah. I mean, we talked about these. If you could like use Athens as like an API documentation tool. So you define the code there, and then it has like the logs of like all of the API requests it makes. Right?
Yeah, there is this thing called dark lane.
Yeah, dark lane is really good.
Yeah. They mix their mix of everything, and also the data store. The data store. Interesting thing.
I think they're shutting it down.
The what?
I think they stopped.
They stopped.
No, I think they did. They spread the team, so they laid off the team.
One of the co-founders left.
Yeah, but the other founder decided to do it alone in a few years in F#, transiting.
Right, let's do F#.
Yeah, transiting from a camel because a camel had bad integrations with GCP. He was suffering from it.
Okay.
Google Cloud Platform.
Have you guys used F#?
Yeah, I use it. Well, I'm not like used, but I fiddled a bit with it when. Well, it's hard. Clojure has its like disadvantages, right?
Yeah.
So sometimes you feel a bit lost, and from time to time I feel like static typing can actually resolve some issues which are happening. And maybe you heard of the talk of the Arcadia developer. Arcadia is a framework for Unity to code in Clojure.
Mm-hmm.
So this guy,
It's a transpiler to their C# interpreter.
It's
yeah.
Taylor.
Because
Yeah.
they have CPI.
Ramsey, I think.
They also have JavaScript, so practically you can write in Clojure script. The Unity supports JavaScript.
Really?
Yeah, you can write JavaScript for Unity.
So this guy,
Unity's nice.
Not doing that.
yeah, he made a talk where he implemented his like toy language in both F# and Clojure, and I think I can find this talk if you're interested. So he is comparing like F# with Clojure, how they're different in their approaches, and that F# is more rigid, and you have the structure of the code, but you have like he said that. Clojure allowed him to hugely simplify his solution just because of this dynamic properties which F# did not allow. So he actually was able to simplify his compiler based
So
on
F# is strongly typed.
Yeah. So it's a really interesting talk if you never heard it.
I don't know. I recently started using a lot of Rust, and I'm a little bit shocked with myself that there was a time when I was writing only in JavaScript, like delivering very huge projects in JavaScript, just keeping everything in my head. Because when you're writing in JavaScript and you don't do it in TypeScript, the IDE is not very efficient.
Yeah.
They're not going to be able to support your your hints and stuff. But after Rust, I don't know. I mean, the type systems. I think that they're very nice. They really do their deed well. And well, obviously there's Haskell and stuff. There's actually the take on Clojure, which has typings and low-level compilation, like car lang. Did you hear about car?
Yes.
It's very like academic. They're now just developing it, but it's practically a compiler in Haskell from Clojure to C code. So it compiles the Clojure, not like Clojure, like some subset of Clojure, very similar.
Bracket or something.
Yeah, like something that it compiles it to C, and then you can compile C with your favorite C, like I don't know, LLVM, but to like the LLVM compiler, I don't know, Clang or GCC, and that shit is actually very cool. I don't know.
It's inspired by NIM. NIM compiles to C, and then
They were trying to initially to just compile directly to assembly, but it didn't work out properly. But it obviously has to have typings. It's not like implementation of JavaScript virtual machine that has like C classes underneath every object. It works for them. I don't know. I don't know. Like the code idiomatically with typings is gonna be larger, but some things are just completely like forget about a certain amount of problems, like in general.
Yeah, maybe you heard of Flix language? Flix. So this is basically the language which is, I think, the first who implements the affect tracking system inside the language. So they are actually wrote a bunch of white papers about it, and they allow for you to like the compiler can.
Is it type first class citizen? Like when I can create type in runtime?
I'm not sure. I don't think
Okay,
so.
sorry.
So it's about like the compiler can designate functions as pure or impure and track the purity of the functions. And I think it's actually can be like really cool. So and they are apparently taking a lot from Haskell community, but with some other.
Compiler can determine if function is pure.
Yeah. So
Isn't
they.
this what Rust compiler can do just in other words, because it can check the borrowing stuff and
Safe and safe.
yeah, it like can practically do that.
Can it like track IO?
Considering that IO is an async operation there, if it's gonna be blocking, then technically it's a pure function. Technically, like just it's practically IO monad in Haskell. But if it's not blocking, then the it can know that the function is practically async. Because if you know if it's async, it's not pure. And Rust tracks everything that goes into the function, so it's not like the borrowing stuff. So it knows that that you're not gonna use like anything outside the scope. You cannot use anything outside the scope of the function because there is a strict borrow checker.
So.
In some way, I'm not saying like this is directly checks purity and impurity, but it can like practically can do this.
Yeah, I just think that maybe this like the notion of purity may be just a bit different with like affect purity and the purity in the Haskell sense, I think. So I'm not sure Flix treats async as impurity,
Mm-hmm.
so that would be one difference. But I haven't actually coded in it. I just tried.
It doesn't treat async as impurity, so it like kind of like continues the evaluation after the async function has completed.
I'm not sure actually. I just don't know. I just assume that there may be this difference which would make sense for affects. Affects are, I think they are implementable for async, so this their purity is a bit different. So they just don't treat async as thing. So yeah, I just think that's one way of like doing stuff. But I don't know if any of you know like a language with a REPL and static type system.
There is a project for C++ done by the CERN, like how is this CERN's like certain scientists that have developed like their own like framework and platform for C++, which is called what's the name of it? Like they have the REPL for C++. Practically, yeah. They have like GT and stuff like that.
Do they have modules and like the next
Some
like
some magic, I don't know. But there's certain scientists like they have one of the best C++ developers, like very academic stuff. They actually diverge a little bit from the C++ like those editions community, you know, like C++ 19, 17 and stuff, because they think that guys in CPPConf they're too much of applied people rather than thinking about academia. So yeah, they have the whole platform and stuff, and they have REPL there.
And that's so definitely started this. We have like 45 minutes left here in this space, but do you want to move to about?
Root, it's called Root.
Yeah.
And also, yeah, I missed the part where I publicly thanking you for being here and having here. It's,
Thank you for having me.
awesome gift. Thank you for doing Athens. it's also due to always.
Thank you for having me. Like, this is a really cool meetup. I haven't been to like a programming technical meetup for like 2-3 years because of like COVID. They're all online, you know, but it's amazing to see that there's such a strong community here.
I really like it.
Yeah, I'm down to like
Просто там 20 у вас стоит дорого, а здесь один. То есть там как бы дешево в Москве. Здесь ниже уже. Но
Что там попить есть?
Есть
Есть шоколад.
ябуджино.
Где?
Едет, да.